journal. The Journal of Global Economic Analysis publishes foundational work in global economic analysis, including theory, methods, data, parameter estimation, and pedagogy. And so we don't publish a lot of pieces, but those pieces that we publish are important, and we believe will have a long shelf life. Indeed, the simple citation index for the JGEA is in the top 3% of all economics journals, as reported by REPEC. So there is significant impact for this work. The JGEA is fully open source. There's no submission fee, no publication fee. It's supported by the GTAP consortium. All the quantitative papers published in the journal are double-blind, peer-reviewed, and fully replicated by one reviewer prior to publication. They come with zip files, which permit the readers to download this information, replicate, critique, and extend the findings. So if you're interested in the research presented today, you can go to jgea.org, download Everett's paper and the associated files, and reproduce the results he's presenting this morning. So I think that's what makes this particularly important and foundational. We'll be featuring a paper today authored by Everett Peterson on the topic of incorporating frictional unemployment into the GTAP model. Everett is professor of applied economics at Virginia Tech University, where he undertakes research in markets and trade. And the work he's presented today was developed in the context of a sabbatical he spent with the Center for Global Trade Analysis at Purdue. We will also have discussant remarks from two of the intellectual leaders in the GTAP community. Bill Powers is chief economist and head of the Office of Economics at the U.S. International Trade Commission, where he leads the analysis of trade and trade policy issues for the U.S. government. ITC is a longtime consortium member and provides financial support and intellectual leadership for that group. Sébastien Jean is director of CEPI. CEPI is a key research and advisory institution on international economics based in Paris. Sébastien is also senior scientist at INRAE, and he's contributed widely to the development of CGE models and policy applications. He's also been a mentor to many of the leading members of the GTAP community. So we're really fortunate to have both of these individuals here today to discuss the paper that will be presented and draw out the broader implications for our community and global economic analysis more generally. So without further ado, I'm going to hand it over to Everett Peterson. And about 20 minutes, Everett, please.
Okay. All right. Thanks, Tom. Okay. So just a brief outline of what I'm going to talk about today. So a very brief motivation, and we'll talk about how I've tried to incorporate frictional unemployment into the GTAP model, and then give an example simulation where I looked at a 25% increase in U.S. tariffs on steel and aluminum, and then briefly wrap up. Okay. All right, so quick motivation, where I'm sure all of you know that the AG models were designed really for medium to long run analysis, right? So the assumption was, well, the length of run is long enough so the labor markets have enough time to return to full employment after any policy shock. But with, some of the recent free trade agreements, the question is, well, do we really go back to the original level of full employment, or do we go to a new equilibrium somewhere? And then the other question is, well, what's the length of adjustment? And so at least today, I'm going to try to address this. The first sort of question is, well, do we really go back, or can we figure out whether we go back to the full level of employment or not? Okay, so to try to do that, right, I mean, there is, quite a long history in CG models or AG models of labor market modeling. I mean, there's an entire chapter in the handbook of CG modeling on people who have tried to do this. So I'm going to focus mainly on some more of the literature and sort of labor economics that looks at frictional unemployment. And so the idea there is that if you have an unemployed individual, they have to go out and look for a job. And conversely, if firms need to hire someone, they have to go out and search for a worker to fill that job. Okay. And so this leads then to a set of matching functions that are based upon the level of unemployment in the economy and the recruitment effort by firms and industries in the economy. And some of the key advantages of sort of this frictional unemployment sort of setup is it's based upon consistent microeconomic foundations. And what we're able to replicate some of the stylized facts, particularly for the US, where there's a lot of churn in the labor market. Okay. So let's take a look at what these matching functions look like. Okay. So we have this matching function. So small m is the number of matches in sector J. 1 minus n is going to be the unemployment rate. RJ is the recruiting effort in industry J. And you can see, since we got a summation of K, it's across all these sectors. And then mu and gamma are parameters in this matching function. So some of the properties of this function is as unemployment increases or as your own recruiting effort increases, you can increase the number of matches. Okay. Conversely, if firms or other sectors increase their recruiting effort, then it becomes harder for you to make matches. So your matches might decrease. There's constant return to scale and all the arguments. And another key feature is there's decreasing returns to your recruiting effort. So the more effort you put into recruiting, the less additional matches that you're going to be able to make. So now that we've got this idea of some sort of matching function, right? We need to think about, some new classes, I guess, of labor for both skilled and unskilled labor. So I've identified 4 sort of labor classes in this new model. So first one is existing labor. So that's kind of the people who don't leave or get turnover their job, right? They carry on their current job. And in the way I've modeled it so far is that I've assumed this existing labor to be sector specific. And one of the main reasons why I did this, and I think Bill will talk more about this assumption later, is that so if a firm has to hire or an industry has to hire new labor, right, they have to pull it out of the pool of unemployed or unmatched labor, right? There's no job switching among people who are already employed, okay? So the next group is called matched labor, that's the newly hired labor. And then we need to identify recruiters, right? Because there's that's part of our matching function. And then there's a pool of unmatched labor where we're pulling, to hire these new people from. Okay. So that also means that we're going to have to change the production structure a little bit in the GTAP model. So everything like in the top 2/3, that's basically the current production structure, right? So what's new is if you look at the very bottom of the slide, we've got a new nest in here where firms or industries can substitute between existing and matched labor. So you might think of, well, maybe an existing worker might be a little more productive than a newly hired one, so they're not perfect substitutes. So one of the implications then, so these elasticities of substitution, so the sigma LU or the sigma LS, if those are finite, right? So if existing and matched are not perfect substitutes, then what's going to happen is that existing labor is going to have varying or differing wage rates across the industries. It won't be a common wage rate anymore because it's a specific factor and it's not a perfect substitute. Okay. The cost in this case of matched labor to the firm is going to be not just the wage that they have to pay for the matched labor, but also what it costs to recruit a new person. Okay, so they're going to be both the recruitment and the wages. Now, one potential drawback with this sort of specification is that if you have an industry with a low turnover rate, right, or you don't have very many new matches, right, there's only so much labor that you could lose, right, or labor employment could go down in any sort of simulation. But as we'll see in a minute, that's really not going to be a problem. Okay, so the next thing what we need to think of then is, well, how do we get an idea of what's the magnitude of this turnover rate or matched labor that is going to be in these different industries? Okay, so I guess what I did was I looked at some of the separation data from the job openings and labor turnover survey of the US BLS Bureau of Labor Statistics, and so on the vertical axis there, you see that percent. So what that measures, that's going to be the the number of total monthly separations, so this could be separations for any reason, divided by the total employment in a given sector, and then I just converted that into a percent. Okay, so it's a little, I know it's a little bit busy, but so if you look at the sort of light blue line, so that's for the US. So if you look for any given month, right, between 2008 and 2017, right, between 3.5% and 4%, you know, around 3.5, between 3 and 4% of the total employment is there's separated every month. So in other words, they have to maintain full employment, we have to hire 3% of our workforce, rehire them every month, right? Because of separations for whatever reason. And, you know, there's quite a bit of variability in the US data across the different sectors. So if you look at like construction and accommodation and food service, you know, they have much higher turnover rates than something like a durable goods manufacturing or wholesale trade. Okay, so we've got quite a bit of churn, at least in the US labor markets. Okay. So kind of taking this then for the simulation that I'm going to discuss in a little bit is, so I'm going to have a model or an example where I have 6 sectors. So I got food and agriculture, extraction, metals, manufacturing, trade and transportation, and services. And so what I try to do is, let me go back here, is take sort of this information and try to come up with what would be like an average separation rate across these sectors for a given year. And I use 2011 because I use the GTAP9 database. Okay. And so what these numbers, so for like metals, right, it says 0.21. So what that means is that basically they have to rehire 21% of their labor every year because of the turnovers that occur during the year. One of the issues with the BLS data is it does not distinguish between skilled and unskilled labor, right? They just give you average turnover rates for all labor. So because of that, if you look at this graph, I mean, skilled labor and unskilled labor, they're basically the same number, or the same number for every industry except for services. And services varies just a little bit because that's a residual category. And I make their turnover rates or their separation rates such that I hit the US total of 36.5%. Okay. All right, so what these mean then is, so like in metals, then that would mean that so that means 79% would be of their labor is existing labor, 21% is newly matched. And so metals for unemployment perspective can only contract by 21% before you hit that specific factor, right? So that's the most labor that they could lose in any simulation, which is, you know, really quite a lot actually. So, you know, there's probably less concerns that we're going to hit this bound or this problem of having sector-specific labor. Okay, so the next thing we need to think about then is, well, how are we going to model labor supply? We got unemployment, right? We got to model labor supply. So I guess what I tried to do was come up with a specification that minimizes any changes to the existing GTAP preference structure. And so what I've assumed, and what others also assume, this is not like an unusual sort of assumption, is that consumption is separable from labor supply. And I'll use an additive constant elasticity of supply function. And so if you look at the bottom of the slide, right, so you got consumption, and then we have these two labor supply functions for unskilled and skilled labor. So that H of U, that's going to be the units of unskilled labor and labor supplied, okay? And for my I'm using the standard, you know, sort of AG definition that a unit is $1 worth of whatever commodity we're talking about, right? So I'm not talking about people necessarily. These are just units, $1 units of labor. The rows, so 1 over rho is going to be the elasticity of labor supply. And these two sides are going to be a disutility from work parameter. And these are calibrated such that the total supply of unskilled and skilled labor, you know, equals what's being supplied in the GTAP database. So since we need to know the unemployment rate in this matching function, right, we need to think about, well, what sort of data is available to come up with that? Well, unfortunately, particularly for the US, right, there's no sort of unemployment rate for skilled and unskilled labor, right? We have data on unemployment rates by education level, right, which is not a perfect match, but that may give us at least some sort of, educated guesses on how these unemployment rates might differ between skilled and unskilled labor. So these unemployment rates that I have here, okay, those are for 2011. So in 2011, the total US unemployment rate was 9%. And you can see there is a pretty wide range between those who did not have a high school diploma and those with a college degree or higher. So in these simulations, I've assumed that the unemployment rate for skilled labor was 7%. So basically, I have no way to weight these different ones, but I just, associate degree or bachelor's, I just try to take a guess on that. And then the unskilled labor unemployment rate is a residual to get me to the total for the US, which is 9%. So, I mean, certainly there'll be some work here on trying to come up with, what are the unemployment rates for skilled and unskilled labor in the GCAP database. Okay, so the last thing we need to do to sort of implement this then is we got to calibrate this matching functions. So there are some empirical estimates of that gamma, and they vary from 0.3 to 0.75. A paper by Halstead and Williams in 2018 that I basically build on their work. They use a value of 0.5, which is what I end up using in my simulations as well. Now, the other thing that we don't have any data on, we have to make an assumption on is, well, how much the initial labor in each section is used for recruitment. So right now, I've assumed that 1% of the initial labor is used for recruitment as compared to Halstead and Williams that assumes 0.5%. And I made that choice a little bit higher, at least to start with, because I didn't want to run into the case where employment dropped enough that the recruiters would go to zero and then the simulation would crash. So I was trying just to avoid that. So the initial number of matches then are going to be the turnover rates times the initial units of labor from the GCAP database. And so once we know the level of unemployment, then the only unknown parameter in that matching function is going to be mu, or the matching efficiency parameter. Now there is one implication for assuming that there's basically the same initial amount of labor is used for recruitment across all industries. And that's going to be the industries that have higher turnover rates, that mu is going to be larger. So in other words, they're going to be more efficient in making matches than in sectors that have lower turnover rates. And this has some appeal, right? Because if you have to hire a lot of people over and over again, hopefully you get a little bit better doing that. Okay, so then the next thing I want to talk about then is just an example. So again, we're going to talk about an example where there's a 25% increase in the tariffs, on the US tariffs on the metal industry, which include ferrous and non-ferrous metals. Okay, so again, there are the 6 sectors, industries that I talked about earlier. I've aggregated the model into 3 regions, the US, the EU, and the rest of the world. All the primary factors, so land, unskilled labor, skilled labor, capital, and natural resources. All of the GTAP parameters that you normally think of, they're all set to their default values. I've set all the labor supply elasticities equal to 1, and the elasticity of substitution between matched and existing labor is 2.5. Okay, so before we get into some of the numbers, I mean, we can just kind of think about logically what's going to happen here when the US places a tariff on imported metal products. So that's going to make them more expensive relative to the domestic metal products. And since metal products are primarily intermediate inputs, what we're going to see is the US firms are going to substitute domestic metals for imported metals. And so that's going to increase the demand for US metals, and therefore their price is going to go up. But that's also going to apply then the cost of production for industries that use metals, like the US, like manufacturing, right, is going to go up as well. So they're paying more for the imported, right, because there's a tariff and the domestic price goes up. So as the price of US manufactured products increase relative to other regions, right, one, we're going to see a reduction in domestic demand, both by firms and by consumers, as imports are now cheaper than the domestic products. So that's going to place downward pressure on U.S. production. But also, we're not going to export as much manufactured products, right? Because now our manufactured products are more expensive relative to those in the rest of the world. Okay, so some of the impacts you might think on labor markets, and well, so in the metal industries, they're expanding production, so they're going to want more labor. Conversely, the U.S. manufacturing sector is decreasing production, and so they're going to need less labor. And what we're going to see, since the manufacturing sector is much larger employment than the metal sector, overall labor demand decreases. Okay? So in the original GTAP model, then we would expect to see that wage rates for skilled and unskilled labor has to fall, right, in order to return to full employment. Okay. In the GTAP labor model, it's going to be a little bit different thing going on in the labor markets because existing labor is sector specific. So in the metal sector, right, production increases, so there's going to be a higher demand for labor, so that's going to drive the wages up for existing labor, both skilled and unskilled labor in the metal industry. And conversely, the opposite is going to happen in the manufacturing sector, right, because their demand for labor is going to drop because production's dropping, and so the wages for existing skilled and unskilled labor is going to fall. In fact, they're going to fall by more than the fall in the wage rates for matched labor. Okay, so that's kind of the verbal description of what's going on. All right, so here's just some of the results. So this first slide is going to look at the impacts on U.S. metals and manufacturing industry. So the first column is just going to be what goes on from the standard GTAP model. So again, output price of metals and manufacturing goes up. Level of production metals increases, it falls in manufacturing. In the GTAP labor model, right, you get the same sort of things, but the price changes is certainly amplified in metals, again, because of the wage, we're going to see in the next slide that the wage rates for existing labor goes up, so that's going to drive up their cost of production. Conversely, there's not as big a price increase for manufacturing because the wage rates for existing labor in manufacturing drop by more, and so that offsets some of the increase in the cost of production from the increase in the metals prices in the manufacturing sector. All right, so given those price changes, then with a higher increase in metals prices, right, we would expect that output's not going to increase as much, and we can see that in the last column. And with a smaller price increase, there's a smaller decrease in manufacturing output in the U.S. Okay. So this next slide looks at the impacts on unskilled labor. The impacts on skilled labor are pretty similar. So again, the first column is the standard GTAP results. So you get an increase in labor demand, right, QFE in the metals industry, and a decrease in manufacturing. And those percentage changes are almost entirely from the expansion effect, right? If we went back to this next, right, because they're almost exactly equal to change in output. And that's because there's very little changes in factor prices. So the wage rates and the capital rental rate are changed basically the same amount, okay? A little bit different story, the GTAP labor model, right? So there's a much smaller increase in the demand for labor in metals or unskilled labor. And in fact, it's much smaller if you go back to the next page than the expansion effect or the increase in output. And that's because of the increase in the wage rates for existing labor in the metals industry. So the wage rate for existing labor, unskilled labor, goes up by about 9.5%. It's a specific factor. You're increasing output, so we know with the specific factor models that the factor price of that specific factor is going to get amplified, right? So that's going to make labor more expensive than, say, capital, right? And so some of the expansion effect is going to be muted by a substitution effect towards more capital, right? So these firms are going to substitute capital for labor, right? So again, the opposite thing is going to happen in manufacturing, right? Because we're going to have a larger drop in the wage rate. So you can see in manufacturing, the wage rate for existing labor drops by almost 3/4 of 1%, which turns to be a larger decrease than capital. And so you get a little bit, so the negative expansion effect gets muted a little bit by a positive substitution effect. Okay, so last thing I'll look at then is the changes in employment by sector. Okay, so again, the units are millions. And again, remember, these are millions of $1 units. Okay, so in the metals sector, right, so we have an increase in labor use. So this is going to be matched labor, obviously, new matched labor, both skilled and unskilled labor. And that's going to require more matches. It's going to require more recruiters. And so they have to employ more recruiters as well. But the drop in labor use in manufacturing, we can see almost totally offsets, any increase in the metal sector. And then on top of that, we can see, also a drop in employment in the services sector. And I didn't have that output on the slide, but we have a smaller decrease in the services sector because of, with these specific factors, because the existing labor, right, we get actually a little bit larger changes in wage rates in the GTAP labor model. And so that actually leads to a little bit larger reduction in income than in the standard GTAP model. And so since services is a huge sector in the US economy, get a little larger income drop, right? So we're gonna have people are gonna buy a little bit less services than in the GTAP model. And so that's being reflected in this drop in demand for skilled and unskilled labor, okay? And so if you convert all these units changes into percentage change, then in this particular example, the unemployment level for unskilled labor goes up by 0.8%, and the unemployment level for skilled labor goes up by about 1.5%. And this would translate into about like a 0.1 percentage point increase in what we would normally think of as the unemployment rate. So in this case, we would go from a 9% unemployment rate to a 9.1% unemployment rate. Okay. Okay, so then to summarize, so I guess, what I try to do here is to incorporate job search frictions into the standard GTAP model. So we've got this matching function based upon level unemployment recruitment effort. And we also realize that firms have to use real resources to fill the vacancies. They had it illustrated on how a tariff on an intermediate input can reduce employment. And then briefly want to talk about some of the data issues. So we've got, data on turnover rates and maybe unemployment rates for the US. But, I've talked with Tom and others before, the question is, well, how available is this sort of data in other regions, right? I mean, we might expect, maybe countries in Europe and in Australia or Japan, those sorts of countries may have similar sorts of data. But there may be other, countries that do not. So the question is, how further can we push this on getting data for other regions? And then, the question is, well, coming up with unemployment rates by skilled and unskilled labor, right? Because there's probably no government agency that's going to report total unemployment rates, not by the skilled levels, right? They might do by education, but that's probably not, a perfect sort of match between skilled and unskilled labor. Okay. So I'm going to stop for questions here, or do I go to the panel?
We're going to the panel first, Everett, and we'll
let me stop sharing this then.
Okay. Then we'll come back for questions. I'm going to reverse the order of the panel. Just Sebastian was tied up in another meeting. Give him a chance to catch his breath and get in the mood. So Bill, if you don't mind sharing your screen and starting the discussion, and then we'll go over to Sebastian. Meanwhile, everyone in the audience, if you could post your questions in the chat, I'll orchestrate things, may in some cases call on you to elaborate on it, or if it's a pretty concise question, I may just pose it, but we'd like to engage you as much as possible. So please post your questions in the chat while you're thinking, while you're hearing the discussion. Over to you, Bill.
All right. Well, thank you very much, Tom. Thank you, Everett. Let me start sharing my screen. Can you hear me?
Yep.
Fantastic.
And we're getting your screen. Great.
All right, perfect. So I'm very excited to be here this morning. Good morning, everyone, and good afternoon, Sebastian, and good evening, I'm sure, to some of you. And here to talk about Everett's paper, provide some comments, and as requested, the U.S. perspective. And just to that point, I want to point out the standard disclaimer at the Commission. These are only my own views. I'm not actually presenting the views of the U.S. government here or the Commission. But that said, what I have to say is informed by a lot of conversations and experience with U.S. stakeholders. So, as this is the U.S. view, and it's an unemployment paper, I just wanted to point out, here is what we have to say about U.S. unemployment rates in the economy over the last 10 or 12 years. And so you can see it, as we all know, what happened in the United States is no outlier here. We had a decline and then a big spike. And just to put this in perspective, right there is where, Everett, your paper was published in this series. You probably had no idea the interest in unemployment that was going to be in the economy when you put that out there or when you put that in. But also for perspective, right there is the highest unemployment rate the U.S. has had since 1940, and close to one of the highest it's had at all time. So where are we now? We've come back a bit from the depths of these unemployment and economic situation, but we're definitely not all the way back. The unemployment rate is still close, not quite twice, but close to twice what it was before the pandemic. All measures in the labor market are elevated and not in a good way. Temporary layoffs, short and long-term unemployment, weekly insurance claims. Those are still 2 to 3 times what they were before the pandemic. It's going to be a while before we get back to normal. This probably surprises none of us. The Federal Reserve predicts that we won't see normal or back to pre-pandemic levels until 2023. That was, I think, the December outlook. Maybe September, the latest outlook. And then even if the economy as a whole gets back to normal, certain subgroups, Latinos and currently Latinos and mothers of school-age children are particularly affected and out of the labor force. And so I expect to see pockets of higher labor issues for years to come, actually, as a result of this. So the focus is definitely on unemployment. So it's great to see an unemployment paper. All right, I've broken down my comments. I've only got a few slides here in the 10 minutes I've got to present, but I've broken it down to why it appeals to economists and then why it should appeal to policymakers. And so Everett, you've done a really nice job of applying equilibrium search unemployment to a CGE framework, and you've basically incorporated the key elements of the Diamond, Mortenson, and Fisurides framework. And so, or another way to think about it is that you're extending Hasted and Williams. They had 2 sectors, and they're looking at environment. And you have incorporated the entire GTAP structure, and you're looking at trade. So either way, what you've got here is new and useful. And when I was reading through your paper, I was particularly impressed by how you managed to get the utility in there. And by making it separable between consumption and leisure, you get to incorporate the existing GTAP equations for product demand pretty much unchanged. And that's super useful because we all know how those work, and we like to, if we can keep using them in the way we have in the past, that's great. And then you have taken some labor extensions, and again, these are pretty much from the Mortenson-Fisurides framework, where you have several types of labor workers. Existing and matched workers, they're actually the ones that are employed in production. And then recruiters, they're part of the cost, they're not in production. They raise the cost above modular revenue product and labor, and that again is a standard feature of a lot of these models. And then when you look at the producer expenditure, they have to pay for all of these things. And Everett, as you were just making clear, the data requirements are, well, you've highlighted the fact that the data may or may not be available in many places. At least the data requirements are fairly parsimonious, and you're very clear in your paper about what they are. And we need labor data and job separation, share of recruiters by region and industry. And you were pointing out maybe the toughest bit is by type of labor as well. So that I should tag that on the slide here. And then along with that, we're going to need some labor elasticities for labor supply and substitution. And then there's a parameter for the efficiency of the recruiters in this matching. So that's something to think about. I'm not sure all of those exist, but you've made some, in the paper, you've made some sensible choices. Okay. From an entirely different perspective, though, I think this paper will be appealing to economists. And that's because it matches a huge wealth of evidence that labor is not mobile, that specific factors is often what we want to think about when we're thinking about workers. Of course, we know Autor, Dorn, and Hansen, which show that workers are geographically immobile and it has important regional effects. We also have evidence far beyond the United States. Topolova, that was India, I believe, and Dix, Carneiro, and Kovac, that's Brazil. And what we see in these, and I'll get back to this towards the end of my comments, is that we see that wages and employment move together. So just to take Dix, Carneiro, and Kovac, we see that when a sector is liberalized in Brazil, wages and employment decline. And not only decline immediately, but they continue to decline, and that difference from other sectors of the economy gets bigger over time. I want to return to that exactly. All right, so that's why it's appealing to me, and I'm assuming other economists. Why do I think this is appealing to policymakers? And I'm going to go back to this mobile labor, this fixed factor. It's not entirely fixed, and I think that's super interesting, and so it works very well. That is a mechanism for labor to move across sectors, but it also has this fixed element. And particularly why this is matching what I think the public and policymakers are expecting is that, as you point out, wages in the directly affected sector move differently than the rest of the economy. In fact, wages in the directly affected sector move in the same direction. Exactly. So here's the same numbers you just presented, just sort of condensed. And again, you've looked at the effects of a tariff increase in the metal product sector. And in your model, in the GTAP labor model, wages and output both go up. And the wages, as you pointed out, in metals are different from the economy. Whereas in a standard GTAP, you would see that wages and output move in opposite directions. And the wages for metals are the same percentage changes in non-metals. One other thing I think might be appealing about this model, matches what we see in the news or in the public's mind and public policymakers, is that your model has evidence of capital being nicely. Your comments are I don't know why here, but there's almost none of that I think happened in GTAP, at least in your simulation. Tom, when you asked me to stand up here a couple months ago, I think it was now, you actually had asked me to talk about the importance of labor markets and the potential of that. So I'm going to finish with those 2 points. I think the importance of labor markets can't be overstated right now. Just getting back to my earlier slides, you can see that current economic conditions are poor for many workers. And then also there's a current political focus on workers, and you've asked me for the US perspective as well. I'll mention that I think that the administration and the Hill right now are very much focused on workers. And you can see that in some of the appointments that are being made to key positions and the statements by the Hill and by the administration. So this is really a focus in the US right now. Why is that? And this is just me speculating, but obviously some of that interest is driven by the current economic conditions. But there's another real, I think, focus of the policymakers in the US, sort of a reevaluation of the importance of distributional effects. So in other words, are trade or trade policy generating inequities or inequalities by gender, race, and other demographic groups? So your paper doesn't comment on that directly, but it does help give us realistic labor movements in the GTAP model. I think that alone is a big step forward. Let's hold on my
Excellent.
for me a second. I'm not quite done. So as you mentioned, you have realistic labor dynamics that shows that we can put unemployment search equilibrium search employment into an equilibrium model. And my question for going forward is that enough? Do we need to be looking at disequilibrium unemployment, which is obviously going to be harder to put into a model. And I think the question that I would like to see answered, and not by you, but in future work, it's going to tell us if this is enough or not. If you put this in a dynamic, what model, what would it look like? And in particular, a couple questions I have here, if my screen would be it. Do we see over time that wages and employment continue to move together, consistent with the evidence that we see in fixed partner and co-back mentioned earlier? Or do we see in other models wages bounce back to the national averages right away, which at least in that paper they argue is contrary to the evidence. Does your fixed labor, does it set a floor for the labor for the employment decline over time? It might. Is that realistic? So these are just some questions to look at if you put this in a dynamic framework. And I think the answer to those questions are going to tell us a lot as to how much further we have to go to get more or perhaps other types of realistic evidence. All right, that's what I've got. Thank you.
Thanks, Bill. Excellent. Go ahead and stop sharing if you would. As I said before, our second speaker is discussant Sebastian Jean, director of SOPI. He's got a lot of demands on his time there, and I'm glad he could squeeze this in. Sebastian, go ahead, and right now I'm seeing Bill on the screen, but I think perhaps when you start talking, you'll be the prominent one. Okay, you got screen sharing, good. Okay.
Okay, thanks a lot, Tom. Let me just make sure that I can, I'm doing it fine. Okay, so apologies first. I made a silly confusions in converting time zones. So I was convinced the seminar would begin 1 hour after what it did, in fact. So my apologies to all, and in particular to Everett, because I missed part of his presentation. But I'm here at the end. I suppose it's the virtual equivalent of missing a plane. So I did it. So thanks a lot for the invitation, Tom and Everett. Really, I'm really excited to be here, if only virtually, and to be discussing this really important and quite challenging issue. Of course, when you are carrying out applied general equilibrium model simulations, you're always faced with naturally demands about unemployment impact, and it's very difficult to deal with them. And as Bill just emphasized, the importance of the labor market of unemployment cannot be overstated, but the difficulty as well to make it compatible with this framework is obvious. So let me start by somehow first making clear that I want to take a step back, not just discuss Everett's work, which is really, I'll talk about it as well, and I think it's really good and interesting, but more broadly speak about what we can learn from this family of models about unemployment. So what do we want to, what do we know that we would want to be able to find in these models? We know that there are employment impact of this kind of liberalization shock. So you're taking the example of a tariff, Everett. I think it's a good example. We could think of a liberalization episode or a variety of structural shocks. We know that they can have an employment impact that is durable, with wide-ranging consequences linked to, for instance, when it is about manufacturing, to wage premia in manufacturing for some categories of skills, linked to the geographical distribution of manufacturing employment, and so on. And this is true in the US, it's true as well in Europe. We know that we are facing European labor markets, which are pretty different from what we have in a simple standard model. It's true in particular in Europe, but of course not only. Unemployment is a key issue. It's structural for a good part of it. The wage structure is sticky, etc. And we are facing significant adjustment cost. We know as well that mobility across regions is limited, The responsiveness to economic conditions, to differentials, for instance, in an unemployment rate is limited, more so in Europe than in the US, even so the difference is not that large, apparently, according to studies. In terms of magnitude, the order of magnitude is that about half the adjustment following a shock is carried out through labor mobility. What I think is also important to bear in mind is that we also know, in particular, from a very interesting study by Dix Carneiro and Kovac about Brazil, that regional impacts may get worse over time. And this is really puzzling to some extent, because this is a kind of dynamics that is at odds with neoclassical theory, and probably driven by slow capital adjustment and by economies of agglomeration. So now, what can we do, and what kind of constraints are we facing when we're using an applied general equilibrium model? Many, but I think the main ones are those listed in this slide. First, that we are working with a micro-funded model. So you need at least to have a modeling of the labor market which is consistent with this framework. And it's also a unique deterministic model, and in that case, of the labor market, of unemployment, and this is, of course, quite challenging. It also needs to be tractable, both for calibration, meaning that you need to have the data to feed in your representation of the labor market, and for solution, it needs to be tractable numerically, preventing too much complexity. It's also a framework that is adapted, well suited to consider medium to long run equilibria. So it's important, I think, to recognize that it's not equipped to deal with short run dynamics. There is nothing in this kind of model to describe the short run dynamics of consumption, of investments, not to speak about financial markets. Of course, this is an obstacle to any short-term analysis, and I'm not fond of short-term analysis using CGI models. I think it's really difficult to make sense out of it. And a third point is that these models are about a counterfactual analysis, meaning a ceteris paribus analysis where other things are kept equal. But in practice, we know that the labor market situation, unemployment, is something closely related to two main leverages in terms of policy: macroeconomic policies, be it a monetary policy, a fiscal policy, etc., and labor market policies. So these are the first order tools to deal with that. And it means that when you're trying to assess the impact of a liberalization agreement, for instance, you're dealing with the impact of a second-order determinants, ignoring the endogeneity of first-order determinants. Paul Krugman has a nice image in that regard, saying that it was like about asking about the impact of wind speed, the impact of wind upon the speed of a car traveling from a country to another one. Of course, the reply is that different kind of wind will not affect the speed of the car. It will just affect your gas consumption, because you have a gas pedal. And in the case of the economy, the gas pedal is macroeconomic policies and labor market policies. So it's very difficult in that respect. So what can be done in practice? There are mainly two dimensions in my understanding. The first one is that we can depart from full flexibility of the labor market. And the second one is we can depart from full mobility. I don't want to be too long, so perhaps I could be brief on that. I'm referring to papers here detailing the theoretical analysis, not in the context of applied general equilibrium model, but in a theoretical context of assuming wage rigidity through different kinds of setup. And the bottom line is that in such cases, the labor market impact is not only transmitted in terms of wages, but also on employment. And for instance, Brescher makes the parallel between labor market adjustment as a Rybczynski effect because it influences the labor input as a result of the labor market adjustment. The second important dimension is to assume imperfect mobility, in contrast to what is done in the canonical model, mobility across sectors or mobility across regions. And both are, of course, of utmost importance. My understanding of what Everett is doing is summarized here. First, I think my feeling is that this is a really elegant work and an excellent work in the sense that you're including an elaborate search and matching model of the labor market in the GDAP model framework. It is micro-founded. I think it's well suited to the objective, and it's calibrated in a way that I find credible with regard to the context and the objective. In practice, it means that in each sector, you have two types of labor: existing labor, which is rigid, and matched labor, which is flexible. And my understanding of the behavior of this model in practice is the following. There is no cross-sector mobility. It's a specific factor model, actually, to a large extent. But with the specificity that you are modeling semi-flexible labor markets at the sector level within each sector. So labor supply is flexible, and this flexibility is calibrated based in particular, not only, but in particular on the separation rates. The wages of matched workers are flexible as well, not those of existing workers, but only the wages of matched workers are flexible. So you have an impact at the sector level distributed between wages and employment. And the result is you have a kind of a specific factor model with sector level flexibilities, which is interesting in being able to deliver an assessment where you have impact on employment and wages orders. I mean, some results as well upon in terms of adjustment costs. Now, given, I think the constraints I described before remain, and given these general constraints, we need to be aware that we are not dealing with the first order determinants of labor market equilibria, and they are endogenous. So in some sense, my feeling is that it means that a CGE analysis of unemployment as a result of these structural shocks cannot be self-contained. There is, in my understanding, there is nothing like the unemployment impact of trade agreements. Why? Because it depends upon macroeconomic responses. It depends upon the macroeconomic background, where what is happening at the same time. It's only a second order determinant. So the capacity of the labor market to adapt really depends upon the starting position and the other things happening at the same time. So we need to be aware of all these cross dependencies and think of this analysis of unemployment as a way to provide useful inputs for a more complete analysis, inputs of what is useful to understand how this specific shock interact with the equilibrium of the labor market and with unemployment in particular. Thank you. I'll stop here.
Thanks, Sebastian. Go ahead and stop screen sharing, I guess. And
Yeah.
I'd like to come back to Everett briefly to respond to whatever he wishes to respond to or emphasize points that the discussants have brought up. Also, I'm just going to pull one, in that context, I'm going to pull one question out of the chat. how have your simulation results for the tariff on metals matched up with what we saw after the Trump tariffs on steel and aluminum were imposed? Stephen Byers raised that question. I think it relates somewhat to what Sebastian was saying. Is this, can you capture the full effect of a policy with, if you're just measuring the wind speed, if you will? Everett, do you want to respond to this? Have you thought about the validation thing in this context? That, you know, the Trump tariffs were kind of targeted and specific. I don't know how much the macro environment changed in that context, but I think it's an interesting question how well this might perform in some cases. But over to you, Everett, to respond in any way you like. You're muted. Yeah.
Am I on now?
Yep, you're good.
So the answer there is no, I really haven't thought that much about it. I guess part of it is because I retired a year and a half ago. What can I say? But I've read some things in like the New York Times, you know, however credible people view that source as. And, there were certainly questions on whether or not like aluminum per se has expanded production maybe as much as our model would have suggested. Apparently, because we can't get into all these, there are ingot production and you've got all these finished aluminum products and all these sorts of things, right, that come into play that, we really just can't get into. So as I kind of remember from the New York Times, it was like, so, Canada produces a lot of some of the ingots of aluminum, and then those are shipped to the United States and they get applied a tariff. And then the U.S. is producing a finished product. And so, it may not be the case that, that production is going to go up for metal products then, right? Because, the tariffs are being applied on an intermediate input again of this finished aluminum product. So, I guess you'd have to really look at these industries and how they're structured maybe a little more in depth than what we can do, at this broad sector sort of level to see whether or not these results are going to make any sense or not. And I guess as far as modeling, I guess one of the things that I guess I've thought of as far as like dynamics is, and I sort of struggled with that when I was working on this static version of the model, would be, maybe so you've got existing and matched labor, but if you think of over time, right, if you get hired today, right, tomorrow you're an existing worker, right, you're not matched anymore. So and the turnover might becomes because either some existing worker either retires, they get another job, maybe they get fired, whatever, right? So I mean, you can think of some sort of dynamics that are coming in there where you're losing, the turnover is coming in existing workers, and then the company has to replace those, through their recruitment efforts, right? So the amount of existing workers could decay over time unless there's some sort of, unless the recruitment efforts, keep pace with that sort of decay over time. And so that might be, that might get into some of some of the dynamics that might be going on. So then you could see, then you might observe, right, some sector whose existing labor is decaying over time just because they're not replacing the people who are leaving, right? Because maybe they want to, their production's going down or whatever you might think of the reasons for that happening. And that's kind of goes beyond what you can kind of do in a static sort of model.
Okay, thanks, Everett. I wanted to circle back to the discussants again. I sensed Bill was more optimistic about this framework delivering useful insights, perhaps, than Sebastian, or not to read too much into Sebastian's comments, but I think he was saying that without the broader context, without knowing how much you're pushing on that accelerator, it might be hard to deliver useful insights. I thought Bill was suggesting there was some value in here in the US context. It may be a US-European thing, or it may be a matter of perspective. But Bill, I want to circle back to you and come back to this question about well, you're in a key position at the ITC, analyzing policies, analyzing these tariffs. In this particular instance, the steel and aluminum tariffs, I'm sure you guys have thought about this a lot. Could you speak a little more to how this framework might have enriched that analysis?
Thanks. I do want to point out that we did not analyze the steel and aluminum tariffs. That was the Department of Commerce. So the Section 232s are actually not under our, so perhaps unusually, and I believe because they're national security related, not under our, we don't have to do that. And in fact, I think we wisely stayed out of that. But I would say how it can more broadly, how it can inform analysis. Policymakers are incredibly interested in unemployment. And so, just talking, and they're incredibly interested in the effects that it's actually producing. And so I think that more realistic analysis of labor markets is super useful. The risk here, which I would, since you asked a follow-up, talk about the risk. The risk is that this may not be the type of unemployment that policymakers expect when we tell them we have unemployment. So I would, if I were to talk about how this tool, to a stakeholder, how this tool helps us, I would say it really helps match some of the regional effects that you have seen come to us to talk about that are important in ways that our CGE models couldn't before, or the ways that workers are, not able to move across sectors or places. I don't know that I would pitch it as an unemployment model because I think that would set up risks in their minds. They don't understand, perhaps. Many of them do, but it took me a while to dig into this paper to figure out what's in there. And I think that we run the risk of selling them a product that they are expecting something.
Thanks, Bill. That's really helpful. I would guess Sebastian wouldn't disagree with that assessment. One thing that I found appealing about Everett's analysis is that it reins in some of this over-enthusiastic supply response that we often see in these models. Without the specific factors, you get pretty dramatic effects that probably, in a validation context, that would be very interesting. Someone out there in this this list of 42 participants might think about actually, if you can find the kind of intervention that where there's not a lot of other stuff going on, can this model better match what's actually observed in terms of wages, employment, and output responses? I would guess it would likely do better, certainly over the medium term. But I think we're just about out of time. I'm going to come back to Sebastian for one last comment if he likes. Even though he missed the plane, he's on the phone from Charles de Gaulle, and we're asking him for one more comment. Yeah.
Yes. Well, perhaps to emphasize again that well, first, I think this is really an elegant way to close the analysis and to deliver something which is speaking in terms of results, which is clear and insightful. And second, my main take is really that in that respect, I don't want to take simulation results as a self-contained analysis of the impact of an agreement or a protection measure, a tariff or something like that. It's an input, and you need to use it in conjunction with other pieces of input to analyze the relevant policy impact because the labor market is too complex to be simply modeled in such a deterministic and to some extent we need to acknowledge also simplistic framework. So it's good, it's important, it's insightful if you know how to take it. So that's the kind of reply I'm trying to convey to policymakers when they ask the question. So we have important information because we know what is the impact on a sector level employment, for instance. So what is the level of adjustment which will be needed in the long term? So we don't know exactly what will be the dynamics for that, but outside the model, you can think of it if it is an adjustment of 1% of the labor force of the sector, or if it is 10%, then you can try to think about it, about flanking policies as well, which of course are important. So it can also be insightful without necessarily giving a figure for unemployment. So I prefer I prefer being vaguely right that precisely wrong. So I think it can also be used this way as one input among several.
Thanks, Sebastian. Very sage commentary there. Everett, you didn't say anything about the welfare impacts. We often talk about welfare impacts, and that's in the paper, but they're much more dramatic in this case. So that's another, I guess, piece to this that people might think about. There's one other a message in the chat from Dominique about rigid real wages. I'm not sure we have time to get into that. Sorry, Dominique, but it's for the next round of discussion. I think we're at our limit here in terms of time. Ginger, one question to you. Could you say something about availability of this for those who didn't hear recording, but also the PowerPoints for those who did participate and would like to see those? Are they going to be available?
Yes, so the seminar is being recorded and I have everyone's presentations, and a little bit later today when the recording is available, I will get everything posted and email it out to everyone.
Excellent. Well, thanks, Ginger, for organizing this. Thanks, Everett, for an excellent presentation. Thanks, Bill and Sebastian, for really super comments. I thought this was a smorgasbord of ideas ranging from the modeling to the policy analysis involving labor markets. Thanks to everyone for participating. A great success, I think, and we'll look forward to the next seminar. Thank you all. You're adjourned.
Thanks a lot.
Thank you.
Thank you, Tom.
Bye-bye.
Thank you, Ginger. Bye, all.